Hello Chem 1B, this is our solutions chapter, video 3. We are going to be talking about saturation, unsaturated, saturated, supersaturated. These are key terms that we use in chemistry to kind of, as a generality, describe how much solute has been dissolved in our solution. Now, the main thing they reference is this is all based on the maximum solubility of whatever our solute is in a solvent. So here in this graph, if you see on the right here, this is the solubility of ammonium chloride in water. Now you can kind of see this red line. This red line is your max solubility of that solute. So, and it's versus temperature. So as we increase temperature, generally with ionic compounds, solubility increases. And so what we see here is that red line is the maximum grams of ammonium chloride that you can add to 100 grams of water and it will dissolve. Now, an unsaturated solution is defined as when our solute, the amount we have dissolved, is less than the maximum solubility. In other words, if I add more solute, it will still dissolve. So anywhere below the red line on this graph, we would call that an unsaturated solution. Now, a saturated solution is defined as where our solubility is exactly the maximum solubility in the solution. So when we say, hey, this solution is a saturated solution of, let's say, ammonium chloride, then we're saying that that solution has the maximum amount of ammonium chloride that can be dissolved at that temperature. So finally, after all those two, we have this other term called supersaturated solutions. Now, in a supersaturated solution, as you might guess, this is where we have somehow been able to dissolve more than what is technically possible at a specific temperature. Now, supersaturated solutions are very unstable. The way we are typically going to make them is we go up to, let's say, 80 degrees and we dissolve the maximum solubility of ammonium chloride at 80 degrees Celsius. And then what we do is we can cool that solution down to maybe 30 degrees Celsius. And if you cool it down slowly enough, the solute sometimes will stay in the solution. And so, and this is typically how supersaturated solutions are made. One of the most common applications of this is with rock candy. If you've ever made rock candy, what you do is you boil water and you dissolve as much sugar as you can in your boiling water. And then you cool it down and you put like a rough surface in there and the crystallization will start to happen slowly. This is because supersaturated solutions generally don't stay supersaturated for very long. They eventually will start precipitating out until we get back to a saturated solution. All right.
It's kind of locked down. So a saturated solution, again, is where we're at the maximum solubility of the solute. No more solute will dissolve. There's probably a small amount of undissolved solid solute present. Supersaturated solutions are where we've somehow dissolved more than the maximum solubility. Now, generally, the way to do this is using temperature. If we remember that graph from the previous slide, we had temperature here and we had solubility here. And if I have like a graph that looks like this, right? Let's say I make a saturated solution at high temp, somewhere up here. As I cool this down, if I cool that solution down slowly enough, I can make another solution, or I can keep the solid in solution, and as you can see, we're well above the maximum solubility at this new temperature. And that's kind of how we do it. If you've ever made rock candy before, you made a supersaturated solution of sugar water. And then you cool it down and you put a stick in there, it'll re-solidify. Supersaturated solutions are super unstable. They won't stay supersaturated for long. Eventually that solid is going to start precipitating out. So it's a temporary state. Again, why? Well, because you dissolved more than the maximum should have been possible at that temperature. So to kind of give you an idea of this, this is a supersaturated solution of sodium acetate. And sodium acetate really precipitates out very fast when you add a piece of solid to it. So it's hard to see here, but right here is a tiny little piece of sodium acetate, and this is a supersaturated solution. So that tiny piece of sodium acetate gives the rest of the solution the perfect excuse to build a crystal off of it, and it'll continue precipitating out until we get to a saturated solution. So after we drop that little crystal in, you can see it dropped, it went down here, and now it's already that big. These two images, I would say probably maybe 1 to 2 seconds apart, to give you an idea of how quickly this occurs. As that precipitation continues, right, another probably between these two, another 1 to 2 seconds have gone past, and you see it's getting quite a bit bigger. The solution warms up because this is an exothermic process, and we continue building a bigger and bigger crystal until, and again, each one of these, like I said, 1 to 2 seconds. This will happen until all of the excess that we have in the solution precipitates out and we get back to the maximum solubility, a saturated solution. It's kind of a neat thing to watch. Normally I would do this demo in class, but yeah, this is the best I got in that.